Okay, good morning, dear students. Welcome to another session of Verilog HDL. So, in today's session, I will be continuing from the previous part where we left off. So, in previous this thing, we started off with the behavioral modeling, in which we discussed the structured procedures regarding initial and always block, and then we discussed regarding procedural assignments, so in that blocking and non-blocking assignments. Then we discussed regarding the timing controls, that is delay based controls, regular delay based controls. Then you had the intra assignment delays and delays using the variables, then zero delay control. So these were a few things what we discussed. Then apart from that, we discussed event based control, how we can declare an event and utilize it. So those also we checked out. So under this, these all things we discussed, and lastly we discussed regarding level sensitive timing diagram, and we started off with a discussion pertaining to conditional statements, in which we discussed regarding if and else statements. So these were the discussions what we had. So pertaining to that, say, using a single if statement itself with no else part is optional. Then using a single if and single else statement, then apart from that, multiple else if statements. So that is what we discussed in the previous session. And we discussed also an example pertaining to the same. So now let us move ahead. We have something specified as multi-way branching. So in C programming, you have seen that we use case statements. So now here what we did in if else, right? Here we had an example. If expression 1 is true, execute this. Else if expression 2 is true, then execute this. So in what happens is if you have say hundreds of these cases, or 10, more than 10, 20, something of these kind of things, then how do I go ahead? So instead of writing if else statements, what we can do is we can use the case statement. We can go ahead with the case statement. So depending on what is the expression value, what is the expression value pertaining to, based on that you'll be able to execute say either true statement 1, true statement 2, and so on. So in the same way we can use the case statement. So instead of going for nested if else if nesting of the conditions, so instead of these things what we can do is we can go ahead with case statement. So what is the syntax for the case statement? Here we have case, which is a keyword, and end case is a keyword. So whatever is there, it should fall within this entire structure, that is within the case and the end case statement. Now, apart from that, we have another one keyword, that is default keyword. So if this is not required, it is optional. It is optional. So now what happens? The same concept as we deal in C programming, right? In the same way, we can evaluate the case statement. So you specify case expression. Based on this expression, right? If alternate one holds for this expression, that is, this expression evaluates to alternative one, then the statement one or statements pertaining to this alternative one will be executed. If expression leads to alternative 2 evaluation, then the statements 2 are executed, and this will continue based on which one is true. If none of them are true, if none of the alternatives are evaluated, that is, expression does not turn on to any of these alternatives what we have provided, then you can go for the default. Say what you have to do by default, what should be the operation that has to be performed. So that can be given in the default statement. So default, then all the statements pertaining to this default action has to be performed here. So this is the syntax pertaining to the case statement. Now here what we have is if within an alternative, if you have multiple statements, right, you can group it in using the keyword begin and end. So let us look at an example pertaining to this one. So what we have here is we have a register which is of 2 bits, which is termed as, this is the identifier ALU control. So this is a register data type and it is in the vector form since it is more than 1 bit. Now you have used the case statement based on what is the value of ALU. Based on what is the value of ALU. So within the brackets, you have put this expression ALU control. Based on what is the value of ALU, we'll be executing any one of these. So for example, if ALU turns out to be what the bits are 00, that is its value is 0. So here what this specifies is it is 2 bits in length, decimal representation. So this is binary representation. This one is binary, this one is decimal representation. So decimal value is 0. So then this statement has to be executed. So next again it is 2 bits, decimal, and the value is 1. That is in binary it is 0, 1 because it is 2 bits. Then its decimal equivalent is 1. Similarly, if it is 1, 0, its decimal equivalent is 2. So here, if decimal equivalent ALU controls decimal equivalent is 1, then next statement is executed. Similarly, the last one. And if none of these are true, then you execute the default statement. You execute the default statement. So based on the ALU control, any one of these will be executed. If default is not there, then it will come out of the case statement. Nothing will be executed within that case statement. Okay. So the pertaining to case, you have case as the keyword and case as the another keyword. Within this case and end case, all your say alternatives and the default should fall in. Okay. And the default is another keyword. So this is with respect to one example pertaining to how you can use the case statement. So in previous this thing we had dealt with the multiplexer, right? Here we have a 4:1 multiplexer. So we had dealt it with using gate level logic, then using data flow modeling, then we dealt it with say the behavioral modeling in different form. So in behavioral modeling, how we can go ahead with using the case statement. So here you have a module which is named as mux421, and this is the parameter list or the port list or terminal list, and this part pertains to the port declaration or the terminal declaration, which is output, which is input, what data type it is. So those all things are specified over here. Now as you know that if it is a 4:1 mux, there will be two select lines. If it is a 4:1 mux, there will be two select lines. So if you have 4 inputs, you should have 2 select lines. So it may be S0, S1, and there will be one output. So that is, it is pertaining to this 4:1 mux. So in this 4:1 mux, so depending on S0 and S1 value, either I0, I1, I2, or I3 will be selected and it will be presented at the output. So here we can see that we are using always, and what you're doing is based on the event change. Based on the event change, well, if there is any change in the event pertaining to these signals, either S1 changes, S0 changes, I0 changes, I1 changes, I2 or I3. That is, any of these statements, any of these variables or any of these variables. So if there is any change, right, then the output has to be altered accordingly. It should be altered accordingly. So for that purpose, what you're doing is this part you are executing, this part that is the always block you are executing whenever there is change in any of these input signals which is present to the 4:1 mux. Now here what we do is we can use the case statement. In that case statement, what you're doing is you are concatenating S1 and S0. S1 and S0. So as per this one is MSB, this one is LSB. So that is so this one S0 he has given. So this is what change he has done over here. So you concatenate both the bits and see what is the result. So for example, if it is 00, so in a decimal, what it is? Decimal, it is 0. So if it is 0, what it implies? It implies that I0 has to be executed or I0 has to be given to the output Y. So this value should be coming over in Y. Okay. So that is what first condition specifies. It is 2 bits in length. So based on this value, in decimal, if decimal equivalent is 0, then out is assigned with I naught. Similarly, if it is say 0, 1, so in that case, what happens? Its decimal equivalent is 1. So if it is 1, then as per logic, I1 should be presented at the output. So that is what is done in this statement. So this is what is happening. Now there might be some conditions wherein S is unknown, or it might be in high impedance state. So in that case, you can put that in default statement that there is an invalid control signal present. So that is possibility. S1 and S0 or I1, I0, any of these can be in any of the forms. So here, based on this S1 and S0, if it is X and Z, or if it is both are X, both are Z, or any combination. So in that case, I don't know which one I have to assign. So what is done? You display a message telling that, okay, there is an invalid control, so please check out. So this is what is happening. So this always statement here, if you just see, this case statement is the only statement which is belonging to this always. Therefore, you don't have a begin and end for this. So this case is the only statement which is present for this always statement. Therefore, no need to worry about the begin and end. Even if you put also, it is not a problem. So this is what is happening. So in this case, what happens is the case statement actually compares 0, 1 and X values bit by bit and position by position. So if they are matching, then only it will execute as per the logic which is present within that case statement. Or else it might throw the values of X and Z, or else it might execute the default statement. So depending on the condition. Now here we have an example with X and Z statements. So what happens in these cases? Even we can use these X and Z cases because we are able to compare it with bit by bit, right? If bits are equivalent, then we can go ahead and check out what logic will be implemented. So here we have a module which is specified as demultiplexer 1 to 4. This is the port list. This part pertains to the port declaration. Okay, this is for the port declaration. Now here, what happens is in demux. So if you look at demux, right, how it will be appearing. So if you have a demux, right, if you have a demux, you'll be having one input and two select lines, and there will be four outputs as per 1 is to 4 marks. So in this case, what happens? Either input changes over here or these two select lines changes. So whenever these two changes occur, right, at that time, the output should be altered. So output is pertaining to whether I0 changes, I1 changes, I2 changes, or I3 changes based on the select lines and based on what is present on the input. So this is how it goes. So here we have always you check the event or the signal that either input changes or S1 changes or S0 changes. Even you can put a comma in between. So that is what we had discussed in previous sessions. So now based on that, right, we have case statement depending on the concatenated result of S1 and S0. You try to see what you'll be executing. So now here a slight difference here is just made. 2 bits is representing this data in binary. So that is, it is 0, 0. Okay, if S1 and S0 is 0, 0, then what I should be doing, I should be presenting the output to 0th one. That is, so as we had seen here, 1, 2, 3, 4. So this is 0, out 1, out 2, and out 3. So this input should be going to the out 0. So what you do is you begin, because there are multiple statements, what you're doing is you're putting those statements in begin and end. So out 0 is in, and remaining what you're doing is you're putting them in high impedance state. So remaining parameters which are there, right? These one, what you're doing is you're putting it in high impedance state. Similarly, for when the bits are 0, 1, you present the out 1 with whatever is present at the input. whatever is present at the input. Rest all what you do is you put them into high impedance state. So in the similar way, what you do is you continue for the rest of the bits. Now there is another possibility that apart from 0, 0, 0, 1, 1, 0, and 1, 1, there can be combination of x0 or 0x, z0 and zx, then xz, zx, then xx and zz. So all combinations are possible. So when these combinations come in, then what is the operation I have to perform? So here what logic they have just specified. So you have multiple conditions now. You have multiple conditions, all leading to, if all are leading to same results, what we can do is in case statement, we can club them with the comma separator. Okay, we can club them with the comma separator or the comma operator. So here we can see that 2 bits, it is in binary. So first bit is X and next bit is 0, or first bit is X and next bit is 1, or X and Z, or XX, or 0X, 1X, or ZX. All these conditions, what he specifies is, he specifies that all of this lead to the same result. So if that is the case, what is the logic he has applied? All output 1, 2, 3, and 4 I are kept in unknown state, that is X state. The output is unknown for each of the conditions. So now if X is present in with any combination, output is also determined as unknown value. Now if only Z is present, X is not there. So what the logic he is following is, it can be Z0, Z1, ZZ, 0Z, and 1Z. So this is a possible combination. All these expressions lead to the same result. So in this case, what you are doing is, when it is Z, right, you are putting all the outputs into high impedance state. So this is the logic how you are following. So case statement can be used for this purpose also. It can be used for this purpose also. So if default statement is there, then you can check out what has to be put forth. Okay. So this is the example pertaining to the case statement with X and Z values. Okay. In Verilog, right, we have two special statements that is pertaining to case Z and case X. So what are these statements pertaining to? So when you're using case Z, right, all the Z values which are present in the expression will be considered as don't care conditions. Will be considered as don't care conditions. So remaining bits can be compared. The other bits will be in don't care conditions. And we had seen that Z also can be represented with comma. So in the starting modules, right, we had discussed regarding these. So it can be represented with comma also. Now this is with respect to Z. But what about case X? So in this one, what happens is it treats both X and Z values as don't care conditions. It treats both X and Z values as don't care conditions. These values are pertaining to the case expression what we are discussing. So here we have an example using say only case X. So here what we have, here you can observe that we have a register data type which is 4 bits in length, and the identify name is encoding. Here we have integer which is specified as a state. Now based on the encoding value, you have to perform some operation. So if you know the encoding, say priority encoding or this thing, so if the highest priority is 1, remaining are don't care. So like that, if you just recollect, so this is how it goes around. So now when we use case X encoding, so what happens is in this encoding, right, any of the values which are X will be considered as don't care bit. It will be considered as don't care bit. So here it is 4 bits in length, and the value is, first one is 1 and the remaining are X values, that is, it is like don't care. So in this one, second bit is 1, remaining are like don't cares. Third bit is 1, remaining are don't cares. Fourth bit is 1, remaining are don't cares. So in this case, what happens is he specifies that the next state is 3. So based on only this bit, right? Only the one bit, you are deciding what is the next state. So here, if I just see the next bit is 1. So based on this, next state is 2. So similarly, you continue up to this one. So this is how you use the case X statement. Okay, and by default, if you have something to specify, you can put it in the default statement. So this is how you can use the case X and case Z statements. So in this case, what happens is if encoding is having X and Z values, both will be considered as don't care bits. So this is how it goes around. Now, for example, if encoding value is 4B10XZ. So what happens is you see that the first bit is 1. So 1 is satisfied, remaining are don't cares. Remaining are don't cares. Even if it is X and Z and 0, it is don't care. So it matches to the first statement. It matches to the first statement. So therefore the next state is 3. So this is what it specifies. So that is what he has given as the next state is 3. Now coming down to the next part, that is loops. So already you have studied a few of the concepts like for and while loop in C programming. So we even here also we have in Verilog we have while and for loops which have almost similar syntax and almost similar logic which it follows around. So apart from these two, right, you have two extra this thing, that is repeat and forever loops. So let us see what is the syntax pertaining to these and how it can be utilized. So coming down to the first one, while loop. So the keyword what you use is while for the while loop. Then what happens in while loop is based on the condition, the while loop keeps on executing unless and until the condition is false. And since the condition is specified, what happens is the increment or decrement pertaining to the variable which is used in that while looping instruction. So we should do it within the body of the while loop. We have to do it within the body of the while loop. Now, if only one statement is there, no need to use begin and end statement within the while loop. But if there are more than one statement within the while loop, right? You have to put it within the begin and end statements. That is the keywords what we'll be using over there. So let us look at the example pertaining to this one. That is in the while loop. So here we have an initial block and we have multiple statements. Therefore, it is put within the begin and end statement. You have done the initialization of the count, since in while we don't have initialization within this structure, we don't have within this structure. So what we do is we initialize the count outside the while loop, and then we execute the while condition and see what has to be done. And if increment or decrement has to be done to that variable, we'll be doing it within the while loop. So here we have while count less than 128. So this loop will be executed depending on the count value. So here we can see that count is initially 0. So 0 is less than 128. What happens is it enters the loop. So if the condition is satisfied, then here these two statements are executed. So it is displaying the count value and it is incrementing the count. So this keeps on repeating from 0 to 127. So this loop will be executed total 128 times. It will be executed total 128 times because initial count is 0. Okay, this is how it goes around. And when count becomes 128, 128 is less than 128 becomes false and it comes out of the loop. So this is what is happening with respect to while statement. Now there is another one, this thing came on, that is example. So here what we have used is we have used the define keyword to define true as 1 and false as 0. That is bit 0. So they have utilized it in the next statements. So there is a register data type which is of 16 bits, which is specified as a flag. There is an integer which will be acting as a counter, and then there is a register called as continue. So let us see what logic they have put forth. So within the initial this thing, you have begin and end. So now you have initialized the flag to some bits, then I is initialized to 0 and continue is initialized to true. That is this value. True implies that it is 1. Okay, this is the value what I'll be using. So it is a hash define. It is a say tick operator, then followed with the define keyword. Okay. So continue is assigned with this hash define value true. So now what we are doing is we are using the conditional, we are using the logical operator double ampersand. So which is ending of these two expressions. So if while I is less than 16 and continue. So if I'm just specifying this, it implies that it should be true. That is, it should be logic 1. So if these two statements are true, then only this entire while block will be executed. Okay, or else the while block will not be executed. So now here we have begin and end. So this begin and end is for this while loop. It is for this while loop. So within this, what you're checking whether the flag of I. So what you're doing, if flag of I is equal to 1, that is logic 1. If flag of I is true, so if that is true, then what has to be done? So in that, what we are doing is we put forth the statements within begin and end. So if this condition is true, you display some information, and what you do is you make continue equal to false. Continue equal to false. So based on this one, right? If I is 0, so it comes in this is false, so it will not be executed. I gets incremented. So when I gets incremented, it points to the next location. Again, it is 0. So the statement won't be executed. So continue will be still true. So when you encounter this bit, right, it is 1. So this statement is true, that is flag of I. It enters and it makes continue as false. So when that is done, right, when you come over here, since this condition is false, this condition is false, while loop will not be executed. So it will be coming out of the loop. So this is what is happening with respect to using the while loop. Now moving further, we have the for loop. So in this one, what happens is in while loop, you saw that if I have to say use I and continue, I have to initialize it here itself outside the while loop. And if I have to check increment, say if I am having condition like this and I'm not incrementing I, then what would happen is it would execute the while loop infinitely depending on the value of I. Since it is 0 and what you're doing is I less than 0 and you haven't incremented it. So this will be continuously executed. It will be an infinite loop. So what has to be done? You have to take care that the variable which is being used in this condition, right, it alters its value so that you come to a terminating condition, or else you'll be in the infinite loop. Okay. So that is what makes a for loop useful for us. So in for loop, what we do is we have initial condition associated with it and the conditional statement which helps us to terminate the entire for loop, and then there is an assignment pertaining to that variable what we are using for controlling. So let us look at the example, and then we can just see how it differs from the while loop. So you have an integer, you have defined it, you have defined it. Now you have within initial block, what you're doing is there is just only one statement, therefore there is no begin and end for this one. So for statement belongs to this initial block. So you have for. So in that, what you're doing is first you're initializing this variable. So that is what the procedural assignment is done. So that is initialization is being done. Now next what you're doing is you are seeing the conditional assignment. That is, the condition. You're checking the condition. So then within that again you have what? You are incrementing the count value. So that is what you're doing over here. You are changing the value of the control variable. So in this case, count is the control variable which is initialized to 0. So this initialization happens only at the starting of the for loop. Happens only at the starting of the for loop. Condition will be checked again and again. And this statement also will be executed again and again unless and until this condition fails. So this is what is happening with respect to the for loop. So here what happens is count is equal to 0. Is count less than 128? Yes, that is initial this thing. 0 is less than 128. So the first time this statement gets executed, count gets incremented, it turns out to be 0 plus 1, that is 1. So 1 is less than 128. This continues. So this display will be happening up to 0 to 127, that is 128 times the loop will be executed. Whereas this thing when we did it with using a while loop, right? So here you can see that you initialize the count. Here you started with the while, and these are the lines what you used to perform the same operation. But the same thing is performed in just two lines of code. Same thing is performed in just two lines of code when you're using for loops. So, but there are some pros and cons when you're using. So, for what this thing you have to go for while loop, for what purpose you have to go for loop. That is, you have to check and utilize it. So, this is the difference between the for loop and the while loop. Okay. So this is pertaining to the for loops. Then we have two extra this thing which is a repeat loop. So the name itself tells that it repeats the loops for certain amount of time. That is, it is depending on certain condition. So here what you're doing is you're specifying everything and then you're continuing. But here we have an advantage, that is you can repeat a certain block or loop with some specification. Now it is like similar like the while loop, but how it is written that we have to check out. So here we have the keyword what is used is repeat for repeat loop. And repeat, uh, what happens is we don't have any logical expression which is present for that. In while what we had, we see that in while statement, right, you have some logical expression while count less than 128. So this is a variable and you're checking the variable. So this is a logical expression what you're checking whether while has to be executed or not. So such kind of expression is not present in a repeat loop. Such kind of expression is not present in repeat loop. So that is one of the difference between this. So how do I repeat a particular loop? So in order to do that, what we do is we use either the variable or we specify the number inside that repeat. So this is the repeat keyword. So this tells that this is a repeat block. How many times it has to be repeated? It has to be repeated 128 times. So no need of initialization, what you have done, nothing you are doing over there, no need of conditional checking, nothing you are doing. You want to repeat it for certain amount of time. So if you want to repeat it, say you have expressed it as y is equal to 1. So you can put repeat y. So depending on that variable, it will be repeating. So this is the difference between a while loop and a repeat loop. So in this one, you're not using the logical expression directly. Either you're specifying the variable name or you're specifying the number, how many times the block has to be repeated. This is same as the while loop what we discussed above. Okay, so that also executes 0 to 127 times. So total it is 128 times. It will be repeating. The same thing is done over here. Okay. So here he has given an example. So here what we have done, we have given the number directly. We have given the number directly. So this number specifies that how many times this block has to be repeated. Now here you can see that you have specified a parameter which is cycles equal to 8. This is a module what he has declared and you are initializing all these things. So here we can just observe in a repeat statement itself. So what he is doing, repeat cycles. So he is using that say identifier over here. So repeat cycles implies that you have to repeat it for 8 times. You have to repeat it for 8 times. I'm not going into the logic of this one. So I'm just trying to see how it goes on. So repeat 8 times. So this block between begin and end will be repeated 8 times. It will be repeated 8 times. So what you're doing is you're basically at the whenever an event of positive edge occurs, you are storing the buffer of I with the data what is present. So that is what he is doing. So this will be continued again and again. Okay, unless for 8 cycles it will be continued because the value is 8 over here. So this is what is happening in case of repeat loop. Now what about the forever loop? So this is like executing the while loop in an infinite way. Is an infinite way. So unless and until certain condition is specified, right, then only you can come out of the loop. Otherwise, it will be executing in an infinite way. So now for this purpose, right, we make use of the keyword forever to define the forever loop. And this loop can be broken when the Verilog encounters or the simulator encounters hash finish task. So this uh, loop will discontinue unless and until it encounters this say a dollar finish statement. If this statement is not executed or not encountered, it may be in the infinite loop forever. So you have to see how it goes around. So it is similar to while one. So this is an infinite loop. If you specify like this, right, it is while one. So within that, you can use the break statement, continue statement. So that has to be. So this dollar finish is nothing like the break statement. Unless and until you encounter the break statement, right, you cannot come out of the while loop. So for Verilog, when you use forever, right, so you have to see that how the dollar finish task has to be executed or when it has to be executed. So based on certain condition is satisfied, then you execute the finish and come out of the forever loop. There is another this thing that is we can come out of the forever loop or you can exit the forever loop using the disable statement. So this is what is happening in this case. Otherwise, another this thing is have to use timing constraints with forever loop. So if you are not using timing control or disable or hash finish, right, then you will be stuck in the infinite loop and the rest of the Verilog code will not be executed. So you have to take care when you're using forever loop. You should be careful when you're using this. If you don't put timing control or disable statement or finish task, so then it will be in infinite loop and it will be continuing forever. So you have to generally what they do is with the forever loop, they use timing control constructs. So that is what we had discussed in the previous session. So that is what they try to utilize. So in this one example is specified, you have a clock, you have initial. So this initial block will be executed only once. Initial block will be executed only once. So in that what you have, clock bit is assigned to 0 and what you are doing is you are executing this statement forever depending on hash 10 value. So what happens is every 10 time units the clock keeps on changing. The clock keeps on changing. Now what happens is since this initial block and the other blocks also will be executed in concurrent in nature, that is at 0 time unit. So if any of these statements have finish hash sorry dollar finish, then it will stop this forever loop. It will stop this forever loop. So in one of the examples we had seen that you execute the hash finish after some 5,000 time units. So 5,000 time units. If this statement is encountered at this moment, this forever loop will be stopped. So when you're using forever, you should be careful. Okay. So what is this statement doing? It is changing the status of the clock every 10 time units. So that's why what happens is its period turns out to be 20 time units based on the simulation time. So here another one example here is specified. What you're doing is you are synchronizing the values of x and y in this case. So you have a clock, you have a register, and what you're doing is forever whenever there is a change in the clock edge, when you're moving from 0 to 1, that's positive edge. Whenever that event is encountered, you initialize x equal to y. That is both you are initializing to or you are synchronizing both the values. So this is what is happening with respect to the loops. So you have repeat loop and forever loop, which are special conditions over there. Now, apart from this, we have sequential and parallel blocks. So sequential blocks till now, whatever we have dealt, right, all are sequential blocks. Then what is meant by parallel blocks? Parallel blocks are defined with the help of fork and another one statement is there within a fork and join. So first this thing, say sequential blocks makes use of the keyword begin and end to group multiple statements together. Then in parallel block, we make use of fork and join. So let us see what is the difference between these two. So what are the different block types? There are two different, that is sequential blocks and parallel blocks. The sequential blocks, what happens with this one? Begin and end are used to group multiple statements together in the sequential blocks. Now, what is the characteristics pertaining to this sequential block? Now, in this one, what happens is, since the name tells sequential blocks, so the statements within this block will be executed one after the other in a sequential form. So that is, the statements in the sequential block are processed in the order in which they are specified, except for one condition, that is non-blocking assignment operator should not be present. If it is non-blocking, then one distinct statement is not affecting the other one. All are independent of each other. That is what we had seen in non-blocking assignments and even in the enter assignment control. So if that is the case, then it goes in fine form. So that is, the statements in the sequential blocks are executed in the order in which they are specified, except for the non-blocking assignments with intra-assignment timing control, only for these things. Otherwise, rest all things are the same. And along with that, if delay or event control is specified, this delay or event control is dependent on the simulation time of the simulator. So what happens is, based on that, that is how this delay and event control will be specified. So for example, what you have done is you have specified something as hash phi x equal to y. But before this statement, there is another one statement y is equal to 1. So this phi value, phi that is hash phi, that is this delay is actually pertaining to this statement, previous statement. So that is what it implies. Okay. So the delay or event control when it is specified, it depends on the previous statement what it is executing. So that's why you see the difference in the execution times. Now let us look at the example pertaining to sequential block. Now here you have reg x comma y, then you have a register which is declared of 2 bits z and w. Now what you're doing is initial begin. So x is equal to 0, y is equal to 1, z is equal to x comma y, and y is equal to y comma z. Now, in previous this thing, we had seen that what is the difference between blocking and non-blocking statement assignments, right? So here, if you just see, this is blocking assignments. So blocking assignments means execution of y is affected by the x is then in the same way z and w will be affected. But which one will be executed at the starting, it is unknown. It is not known. So that is one of the problems. All the executions start at time t is equal to time 0 units. So here what happens is, depending on the values of x and y, z and y values can be altered. Now here for the first illustration, what they have given for this one. So here what is happening? X is assigned with 0, y is assigned with 1. Therefore, z will be 0, comma 1. That is, it is 1, and w is 1, comma 0, which is 2. So these two values are specified. Now here this is without delay. Now with the delay when we specify, So here he has given in example 7.21 statements in the sequential block for the in illustration 1. The final values are x is equal to 0, y is equal to 0, z is equal to 1, and w is equal to 1 at simulation time 0. Now in the second illustration what he has specified, the final values are same except that the simulation time will be altered. Okay. So here what happens is, so all these statements will be executed at 0 time units. At 0 time units. But in this case, what happens is, if you just observe, we have declared x, y, z, and w. In the initial block, we have x is executed at 0 time unit. So at time 0, x will be assigned 0 value. Now hash phi is specified, right? Y is equal to bit 1. This phi is dependent on the previous statement. It is dependent on the execution of the previous statement. So previous statement was executed at 0th time unit. Phi specifies that you execute this statement after 5 time units of this one. So it will be 5 time units for this statement to be executed. So at time 5, this statement gets executed. Now you have hash 10. So this doesn't mean that at 10 time unit it will be executed. So what this does is, this is dependent on the previous statement, that is hash phi y is equal to 1. So in this case what happens? So previously 0 was there, then this one took 5 time units. So from that 5 time units, you wait for a time 10 time units, that is which equates to 15 time units. So at time unit 15, right, this execution will be done. So then after 15 plus what you have, since there is hash 20, right, after 15, that is from 15th time unit plus 20, so it will be like it will be 35. So at 35 time units this statement will be executed. So previously in this one, there is no delay specified. At 0 time unit, everything is over. But in this case, what is happening? It will take around 35 time units to complete this entire block. To complete this entire block. So that is what is happening in the sequential blocks. Then what about the parallel blocks? So in parallel blocks, we make use of the keywords fork and join. So with respect to this, what we have, the statements which are within the parallel block are executed concurrently or parallelly. All at once they start off the execution. Now ordering of the statements, because parallel execution is there, if you want to delay it, right? If you want to alter the execution of each other, then you have to make use of the delay or the event control. If you don't use it, then there will be some mismatch happening. So you should be careful. You should be careful when you're using parallel blocks. If delay and control are not specified, then relative to the time of the block it was encountered. That is, when you are using this, right, you should check out which block will be executed at what time, which is a very difficult thing to do around because it depends on the CPU, it depends on your simulator, everything. So in this case, what happens is, so here we have one example what they have specified. So how it is different from this sequential block. So this took around 35 time units to complete its execution. Okay. Now in parallel block, what we are doing is we are specifying initial fork and join are used. Within this, these statements are falling. Since fork and join are present, right? These are acting as, this is the parallel block. This entire thing is a parallel block. And these statements will be executed in concurrent form. So what is concurrent? All will start their execution at time unit 0. Whereas in the previous case, what was happening here? This statement will wait for the previous statement to complete its procedure. Next statement will wait for the previous statement to complete its procedure. So that is how 0 plus 5, 5 plus 10, 10 plus 15, 15 plus 20. So total 35. But here that is not the case. So what is happening at time unit 0, time unit 0, x will be assigned the value because there is no delay. So from 0 to 5 time units of delay, that is at 5 time units, y statement will be executed. From 0, that is up to 10 time units, z will be executed. From 0 20 time units, y will be executed. So what is happening? Previous one took around 35 time units to execute, whereas the parallel block took around 20 time units to execute. So this is all for this chapter.